Welcome to David Alexander Maths Tuition. This is chapter 3b on arithmetic series. Okay, so if I asked you what is the sum of the first 100 numbers, I imagine unless you're in a very small percentage of the population, you probably just grab your calculator and go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, etc. all the way up to 100. Well, that's certainly what I would do. But there was a famous mathematician and also a student of mine who was only about 9 years old that thought of a very clever way of doing it. So you don't actually need to write it down. He did this in his head. By thinking of the numbers as 1 all the way through to 100, I've just written them down for convenience, and then writing them in descending order underneath. So the sum of the first 100 numbers is all of the numbers in this blue row added together, and it's also the same as all the numbers in the row underneath it added together. So what I've done is I've got two lots of the first 100 numbers in these top two rows. Now, by writing them in ascending and descending order underneath each other, we can see that 1 plus 100 is 101, 2 plus 99 is 101. So all of these totals are 101. So what we have is 100 lots of 101, and this is double the sum of the first 100 numbers. So what we need to do is simply half that answer. So the sum of the first 100 numbers is 100 times 101 over 2, or 50 times 101, and that comes to 5,050. So if you're trying to work out the sum of the first x numbers, it's n, which is how many numbers there are, multiplied by the first and the last, all over 2. In other words, here n is 100, the first is 1, and the last is 100. So that's my 1 times 101, and again halved. So the sum of the first 2,000 numbers would be 2,000 multiplied by 2001 over 2, and that would be the same as 2,000 divided by 2 is 1,000, so 2001, too many zeros there, 2001 times 1,000, so 2 million and 1,000. Okay, so the formula for the sum of the terms of an arithmetic sequence, in other words, an arithmetic series, is this formula here, n over 2 multiplied by 2a plus n minus 1d. So let's say so this is given to you in the exam, so as long as you are aware of its existence, then you don't really need to watch much more of the video, just use that formula. But let me just prove where it comes from. So let's say we've got a sequence that starts with our first term a and our last term l. So each term we're adding on a difference. So the second term is a plus d, third term a plus 2d. The penultimate term will be l take away d, and the term before that will be l take away 2d. So there's my sequence written out, and if I write out the sequence again but in reverse order, then it's going to go l minus d, l minus 2d, all the way down, or all the way up to a. So I've written out the sequence twice. Now if I add the two sequences together, I'm going to end up with a plus, all these a plus l's. So the sum of the series will be n, the number of terms there are, n lots of this a plus l halved. Now the last term, well, what are we going to do with the l? So the last term has the nth position, and we know that the nth term is a plus n minus 1d. Every term is the first term plus the number of differences multiplied by the number of terms there are, take 1. So therefore ul is going to be the same thing. It's a plus n minus 1d. Because in this sequence n is l. The last term is what was the final term in the sequence, which is the n number of values. Anyway, so what we can do is we can replace this l with, so it's going to be n lots of a plus n minus 1d, and that's all over 2. So therefore the sum of the series is n lots of 2a plus n minus 1d all over 2. And again, this over 2 was normally written as n over 2 lots of 2a plus n minus 1d. Okay, perhaps I didn't explain that as best as I could, but again, you don't really need to fully understand it. It's unlikely you're going to be asked to prove it or anything like that. It's highly unlikely, I would say, as long as you are aware of the formula's existence and how to use it, which we'll do in a few more examples, then I'm sure you'll be absolutely fine. Okay, so here are some examples. So the formula, remember, is n over 2 lots of 2a plus n minus 1d. So we've got 50 terms, that's 50 over 2, which is 25, times by 2a. So let's just maybe make a note of this. So n is 50, a is 5, and d, the difference is 4. So just substitute them in basically. So 2 lots of a is 10 plus n minus 1, which is 49, times by d, which is 4. So grab the calculator. I'm going to do 49 times 4 plus 10 multiplied by 25. That's 55150. In this next term, a is 6, n is 25, and d is negative 3. So again, it's n over 2 lots of 2a plus n minus 1d. So n over 2, that's 25 over 2. 2 times a, which is 12, plus 24 times by negative 3. So 24 times negative 3 plus 12 times 25 divided by 2. That comes to minus 750. And this is going to be negative because we're adding together lots of, well, there's only two positive terms and then the rest will be negative. So it's not a surprise that the sum of the series is going to have a negative value. Okay, these two examples are similar-ish. The only thing is we don't know how many numbers there are in the sequence. We know that 85 is the last, so we know that un is a plus n minus 1d. So 85 is a plus n minus 1d. Well, a is 9 and the difference is 4, so that's plus 4n take away 4. So 85 is 4n plus 5, so therefore 4n is 80 and therefore n is 20. So we've got a is 9, n is 20 and d is 4. So it's again the same formula, n over 2, 2a plus n minus 1d. So n over 2, that's going to be 10, lots of 2 times a, which is 18, plus 19 times the difference of 4. 19 times by 4 plus 18 is 94, so times 10, that is 940. Okay, again, these sequences are quite, well, it's a series because we've got the addition sign here, but if it was just the values 4, 10, 60, we can easily work out the nth term. We could have done this at GCSE, going up in sixes, so that's 6n take 2. I'm going to set that to 76, so therefore 6n is 78, and 78 divided by 6 is 13. So n is 13. So again, we're going to do the n over 2, lots of 2a plus n minus 1d. So that's 13 over 2, 2 times 4, which is 8, plus 13 take 1, which is 12, multiplied by that difference of 6. So 12 sixes are whatever, plus 8 is 80, times 13 divided by 2, and we are getting 520. So this is a different style of question. We need to work out how many terms are needed to get this following sum. So what we know is that n over 2, lots of 2a plus n minus 1d equals 1032. So what I would do at this part here is just multiply through by 2. Just simplify it a little bit. N lots of 2a plus n minus 1d is double 1032, so 2064. Now we don't know what n is, but we know that a is 12, so 2a is 24, and we know that d is 7, so that's going to be plus 7 lots of n minus 1, so 7n take away 7. So that's going to be n lots of 24 minus 7, which is 17. So 17 plus 7n equals 2064. So expand the bracket, 17n plus 7n squared equals 2064. So we'll end up with a quadratic with these ones. So let's make it equal 0. 7n squared plus 17n subtract 2064 equals 0. Grab the quadratic equation solver on the calculator. 7, 17 minus 2064, and we get n is 16. So there we have it. So n is 16. So that's the number of terms needed to get the arithmetic series of 1032. Okay, so let's look at this second example. So here we know that n over 2, lots of 2a plus n minus 1d is negative 480. So if I double it, n lots of 2a plus n minus 1d is negative 960. We don't know what n is, but we know that a is negative 5, so 2a is negative 10. And d is, the difference is negative 2, so that's going to be minus 2, lots of n minus 1, equaling negative 960. So that's n lots of minus 10 minus 2n plus 2 equals negative 960. So that's going to be negative 8. So n lots of negative 2n minus 8 equals minus 960. So what we have is negative 2n squared minus 8n plus 960 equals 0. Use the quadratic equation solver on the calculator and n is 20. There we go. So 20 terms will give us negative 480. And if we want, we can work the formula backwards. If we just wanted to test it, put 20 into our formula, and as long as we get negative 480 at the other end, then we know we've definitely got it correct. Okay, so find the sum of the first 80 even numbers. So 2, 4, 6, 8, etc. So what we have here is, well, we are adding them together. So 2 plus 4 plus 6 plus 8. So we have an arithmetic series. So we've got n over 2, 2a plus n minus 1d. Now n is going to be 80. A is 2, and the difference, we're going up in 2s, is 2. So fairly straightforward. 80 over 2, which is 40. 2 times a is 4, plus 79 multiplied by 2. 79 times 2 is 158, plus 4, and then multiply that by 40. So the sum of the first 80 even numbers, that is 6,480. So for this question, what we're going to do is we are going to do the usual n over 2, lots of 2a plus n minus 1d, and we're going to set it to exactly 585. Now, I'm pretty sure that when I set it to 585, the value for n that I get will not be a whole number. So I'll need to round it up. So again, we don't know what n is, but what I'm going to do first of all is just double everything. So n lots of 2a plus n minus 1d is 585 doubled, which is 1,170. Now here we know that a is 3 and d is 4, so that's n lots of 6 plus 4 lots of n minus 1, so 4n take 4 is 1170. So that's n lots of 2 plus 4n equaling 1170. So 2n plus 4n squared take away 1170 equals 0. So quadratic equation solver to the ready. So that's 4n squared plus 2n minus 1170. And we can see that n is 16.85. So n, remember, must be a whole number. So if I've got exactly 16.85 terms, I will get exactly 585, but I want to get more than 585, so therefore I will need 17 terms. 16 terms will be less than 585. 16.85, well, I've rounded it anyway, will give me exactly 585, plus doesn't even make sense because, like I say, if you're queuing for concert tickets, you're either 16th or 17th in the queue. You can't be 16.85, but 17 is the first value. When I stick it into the formula, will exceed 585. So here, n is 17. Okay, here's another example. The first term of an arithmetic sequence is 9, so a is 9. The sum to 50 terms is 7,800. So what that means is n over 2 lots of 2a plus n minus 1d is 7,800. Okay, so I'm sure that with this information I can work out what d is. Now, if so we know a is 9 and n is 50, so 50 over 2 is 25. So it's 25 lots of 2 times a, which is 18, plus n minus 1, which is 49d, and that equals 7,800. So rather than expand the brackets, I'm just going to divide through by 25. So 18 plus 49d equals 312. Take away the 18, it's 294. So 49d is 294. Divide that by 49, and the common difference is 6. So d is 6. Okay, the 10th term. So we know that the u10 is going to be a plus n minus 1d. So that's going to be 9 plus, well, here the nth term is 10. Sorry, the value of n is 10. So 10 take away 1 is 9. So that's going to be 9 plus 9d. And we know that d is 6. So 9 multiplied by 6 plus 9, the 10th term is 63. There we go. Okay, here's another example. Now we know the 19th term is 222, so that is a plus 18 differences equals 222. The sum of the first 4 terms is 118, so n over 2, lots of 2a plus n minus 1d is 118. So if there's 4 terms, that's going to be 2 lots of 2a plus 3d equals 118. In other words, 2a plus 3d is 118 divided by 2, which is 59. So I've got some simultaneous equations here. A plus 18d is 222, and I've also got that 2a plus 3d equals 59. Well, if I double this equation, then the a's will balance. So that's going to be 2a plus 36d is 444. I'm going to subtract one from another. I'll subtract the top from the bottom. So that's going to be 33d is 444. Take away 59, which is 385. And if I divide that by 33, so here d is 35 over 3. There we go. And now I can work out what a is by multiplying that by 18 and subtracting it from 222. So therefore a is 12. I'd probably go back and double check that because I'm always a bit suspicious when d is not a whole number. There's no reason why it can't be, of course. So let's just assume that that is correct. Okay, so here's a proof question. Prove that the sum of the first 16 natural numbers is 183 over 60. So that's 1 plus 2 plus 3 plus 4 all the way up to plus 59 plus 60. And we know that this is the same as 60 plus 59 plus 58. So what we have is lots of 61s. So it's going to be 60, lots of 61s, halved, and that is the same as 30 multiplied by 61, and that is 1,830. So it's exactly the same as I think the very first question that I did in this chapter. There's a couple of questions like this in the book, so as long as you just remember that, then no problems at all. Okay, so here's another proof question. Show that the sum of the first n even numbers is n squared plus n. Okay, so we know the formula is n over 2, lots of 2a plus n minus 1d. So here n is just n. Now a, the first even number is 2, and if we're talking about even numbers, 2, 4, 6, 8, we're going up in 2, so the difference is also 2. So what I have is n over 2, lots of 2a, so 4, plus 2 lots of n minus 1, just sticking the value of the d in front of the bracket there. So that's n over 2, lots of 4, plus 2n take 2. In other words, n over 2, lots of 2 plus 2n. n over 2 times 2 is n. n over 2 times 2n is n squared. So there we have it. I've shown that the sum of the first n even numbers is n squared plus n.